Hi, my name is Julian. The goal of this video is to explain Marslink.io website, which is a simulation of the solar system and a constellation that orbits the Sun to connect the Earth and Mars via an internet link. So on the left side, you have a few user inputs. On the middle, of course, you have the simulation itself. And on the right side, you have some outputs. I'm just going to go over some of the important inputs. First of all, you have a display option here of 2D or 3D. The time acceleration if you want to look into the future or the past, and note that you have the date on the bottom right of the screen. The maximum link range means that the calculation will not consider links that are beyond a certain size. This is in astronomical units. And the allowed flow calculation time means that the flow calculation, which is the blue and red thing you see here, that will not exceed the number of seconds set here. This is to ensure that there's some fluidity once you set some parameters, that the simulation doesn't freeze, for many seconds when it's calculating. Here you can set the cost of the satellites and the Starship, capability of how many laser terminal per satellite. This is the current performance of the technology. This is preset on the known Starlink laser technology, but we can also improve this with the technology improvement sliders here. Here we can set the ring Earth. So this ring here, which is a partial ring, you can extend it or reduce it. It extends, above, like either side of the Earth. You can make it full as well, but and also you can set the throughput in the ring, which is the case for any rings. The same goes with the ring of Mars, which can extend here, or you can, reduce. Then you have like the circular rings. So here there's 3 of them, but you can increase the number to, well, essentially as many as you want. And you can increase the speed within the ring. So here I can increase, that really increases the number of satellites. You can set the distance of the outer ring and the distance of the inner ring. And then you can also set the inclination, which you can see here. We'll go closer to the Earth at 0%, equal at 50%, and closer to Mars at 100%. I like to keep it at 50. And the same goes with the eccentric rings, which we don't have them here, but if we add them, well, that's eccentric rings that we can add with some relevant parameters to that. If we look on the right side, we have the number of satellites, starships, and tankers, the total cost and the breakdown. The cost here per megabit per second, the actual total throughput at the moment, but notice that if you look at other dates, the throughput actually changes because the topology of the network does change. And we also calculate the latency. As an example, right now, about 300 megabit per second, and the latency between 21 and 32 seconds. This chart here reflects the actual latency of like all the links in a histogram. And then the deployment report is quite interesting. It shows you what is the schedule of deployment in terms of the fuel required and the number of tankers required. And this is if you want to simulate over a longer period of time to get some results. And here's the Marslink deployment report. So with what we've designed here, we have a technical summary with all the links, all the rings that we want. And here the number of tons of propellant that we want, the number of tanker flights, of satellites per deployment flight, etc. We have a financial summary based on some assumptions here for cost. And here, for example, the total cost is that. So it's in $1 million, so that's 2.3 billion. This specific design. And in terms of each individual ring, well, you can look at the detail here, including the launch schedule, for lack of a better term, where you have like the liftoff of the entire booster and Starship, and then you have separation, you have the in-orbit refueling coming from this other launch of the tanker. But some rings require more tankers than others. And the tankers don't always fly full. Actually, as a matter of fact, they don't always fly full. Anyways, that's a 5-minute video explaining the Marslink website. Thank you very much for your attention.